Okay, this video lecture is over Chapter 11 of your textbook, which covers inheritance. In Chapter 10, we talked about the basics of object-oriented programming, and inheritance is one of the very key aspects of object-oriented programming. So this is a pretty short chapter that covers inheritance. In particular, we're going to talk about what is inheritance, and then we're going to talk about what polymorphism is, another characteristics of object-oriented programming. So what happens is they start talking about this in specialization. I think in the last lecture I gave some examples of you have cars, and you might have antique cars, and you might have sports cars. What they're doing here is talking about insects. So we might have a class or an object called insect that has some general characteristics about an insect. However, we might have specializations, or what's going to end up being called subclasses of insect. So, for example, we might need to talk about grasshoppers, and grasshoppers will have different behaviors or different information that we need to track about a grasshopper as opposed to another insect such as a bee. So they have some common stuff, and then they have some other things that are not common. So looking at a diagram, we have a class insect, and then from that we're going to subclass that into bumblebee and grasshopper, and put the aspects or information that is relevant to those. Inheritance, we have a thing in object-oriented programming in general called ISA, and basically, grasshopper is an insect, bee is an insect, rectangle is a shape, daisy is a flower. So basically we have the specialized object that is a more general object with common attributes. So inheritance is used to create an ISA relationship. So one object is another object, or really I should say class. So the superclass is the class higher up in the hierarchy, and they're saying it's a general class. And the subclass is called a derived class because we take the superclass and extend it. So when we subclass an object, we're going to inherit all the attributes and methods of the more general superclass object, but we're going to be able to add new attributes, add new methods, and one thing that they don't mention yet is override methods that we have in our superclass. So, for example, if we're going to create classes for cars, pickups, trucks, and SUVs, all of these are automobiles. And an automobile has a make, a model, a year that it was created or made. It has a mileage, and it has a price associated with it. So these are kind of general things that all of the cars, pickups, SUVs have in common. In addition, and there's some crossover here, like cars has a number of doors. Is it a 2-door? Is it a 4-door? Well, these days pickups can have 2 doors and 4 doors as well. But we assume maybe that's more relevant for a car and not a pickup. Pickup truck, maybe two-wheel drive, four-wheel drive, all-wheel drive. Well, in the past, that was something you had on pickups. And like I said, things are kind of blurred these days. You have all those, or at least some of those available to a car. And for SUV, maybe you want to specify how many people it will seat, or the passenger capacity. So if we kind of go with what they've outlined here, this is what our automobile class is going to look like. We have an init method, and we always have to pass self in, but we're going to do the make, the model, and the mileage and the price. And then contained within this object, we're going to have private variables. They're private because they start with 2 underscores. So make, model, mileage, and price. And then we can set the make, we can set the model, we can set the mileage, we can set the price. And then we have getter methods for all those as well to return the make, the model, the mileage, and the price. So there's our 4 instance variables, and then our 8 methods that we have within our class. So if we want to subclass this, we're going to start with the keyword class. We're going to give the name of the class, and then we're going to pass it in its superclass. So car is a class that inherits or is a subclass of the automobile class. The initializer method in subclass is going to call the superclass's initialization or init routine to initialize all of its data attributes, and then it's going to initialize the data attributes that are within the subclass. And then, like we saw before, we can have methods that might be unique to the subclass. So looking at that, we define a car. It's an automobile. We call the init, which calls the automobiles init, and then it's going to set the number of doors. And then we have all the methods we had before for make, model, mileage, and price. But one thing that's specific to the car class is that doors data attribute. So we're actually going to add 2 methods, one for setting the number of doors and one for returning the number of doors. As far as a truck, everything's the same except the data type that's added is drive type. And then we have methods for setting and retrieving or getting the drive type. And then finally for SUV, same thing. It's data attribute that's specific to the subclass SUV is pass cap, which is the passenger capacity. And then we add methods for being able to set and retrieve that private variable. If we look at a UML diagram, it's going to look like this. We're going to have the same type of boxes. That is 3 things. The top box is the class name. The middle box is the data attributes for that class. And then the third box is the methods that we have for that class. And here we have an up arrow, which basically means car is an automobile, truck is an automobile, SUV is an automobile. And also another way to say that is car is a subclass of automobile, or car inherits from automobile. So there's a lot of information conveyed here in several different ways to talk about the information that's conveyed here. So you see in the subclass we don't repeat all the things that are in the superclass. We just do the added data attributes and the added methods for each of these. And I'm not sure why. I guess because we need to know what to pass into it. It does show under the methods the init method for the subclasses. Polymorphism is the ability of an object to take on different forms. It is the ability to define a superclass, take a superclass, define a subclass, and then override or change a method based on what you're doing. So kind of the best analogy I can think of this is in Python, in the language itself, the plus sign. If we have number plus number, it is going to perform the mathematical operation addition. But if we have string plus string, it is going to perform the string concatenation function. So basically what polymorphic behavior is looking at the object itself and determining what method should be called. So in Python and object-oriented programming languages just know how to do this. So in the previous examples we showed how to override the init function, possibly calling the superclass's init function. We can actually do the same thing for objects for any other method. It doesn't have to just be the init method. It's just the init method is very common and almost always called. So here we have a mammal class, and within the mammal class we have a private variable called species, and then we subclass that into a dog and a cat class, and basically both of these have a make sound method, but if you're a dog you say woof woof, and if you're a cat you say meow. So we have the same method name as the mammal class, which sound is grr. So if you're a dog, you're going to say woof woof. If you're a cat, you're going to say meow. And if you're some other species, you're going to growl, presumably. So what we do is we import our class library, and then in main we create a mammal that is a regular animal, and then we create a dog and we create a cat. So the first thing we do is we call show mammal info, and then after that we have another method called show mammal info, which is going to show the species and the sound, and then we're going to run the main program. So the main program creates those objects, and then the first one says I'm a regular animal and it growls. Second one says I'm a dog and it says woof woof, and the third says I'm a cat and it calls meow for the make sound method. There is an isInstance function that you can use. It determines whether the class, or I'm sorry, whether the object is of a particular class or not. And the reason we want to do that is because if you are one type of object and you try to call a method that is not associated with the particular class, then you're going to get an attribute error exception. So to try to avoid getting this exception, we can say, for example, down here, isInstance object class. So object is an instantiation of an object, or an instantiation of a class. It's an actual object. And you're saying, is this basically of type class? Is it a member of that class? So that's very handy to try to avoid getting runtime errors. So that, like I said, was a really quick chapter, really quick discussion on polymorphism and inheritance. So this last slide is just a summary of some of the key points we talked about in this chapter.